Welcome to the web-based training module on power transformers. This training course will cover the general function of transformers. However, in this course we will focus on power transformers. This means that we only cover transformers designed for high power ratings, such as for electricity transmission and distribution, and special industrial applications with power ratings in the kilovolt and megavolt ampere range. Transformers for consumer electronics are not covered in this training. Any learner is welcome to take this training course. This includes technicians and engineers, as well as people with a more finance or business-focused background. From this training you will gain better understanding of the basic electrical principles of power transformer technology and greater insight into the dynamics involved. Once training participants have completed the course, they will understand the basic function and the individual transformer components, and how to operate transformers over their long life cycle. This training is structured in 4 main sections. At the beginning of this training, we will cover some basics of the general function of transformers, including a few physical equations and why high voltage is required in power transmission. The second section of this course will explain the various types of power transformers. In the third section, we will take a look at all components used to build power transformers. The final section will cover the life cycle of the transformer, from its initial planning for a project to its construction, operation, and maintenance. Let's first take a look at the invention of transformers. The first patents for transformers were granted around 1882 and 1887. During that time, 2 electrical grids were competing in the United States: Edison's direct current, DC grid, and Westinghouse's alternating current, AC grid. With transformer technology, it was finally possible to reduce the electrical losses of AC grids. In this way, AC technology won out over the DC grid. In 1891, the first large 3-phase power transmission line was put into service. Power generated in the town of Laufen, Germany, on the Neckar River, was transmitted over a distance of 176 kilometers to the International Electrotechnical Exhibition in Frankfurt am Main. Downstream of the generator, which had a terminal voltage of only 55 volts, a series of transformers rated between 100 kilovolt ampere and 150 kilovolt ampere, built by Oerlikon and AEG, today Siemens AG, stepped up the voltage to 15 kilovolt. The inset photos show the early days of the transformer production factory in Nuremberg, Germany, which today is home to the global headquarters of Siemens Transformer Business Unit. While the basic principle has not changed since the invention of the transformer, transformer technology has continuously improved right up to today to increase power, raise the voltage, lower operating losses, lower the price, decrease the usage of material, and decrease size. Today, Siemens is the leading manufacturer of high-end transformers with very high power and voltage ratings, which are only limited by transportation issues. Above a certain size, 1300 megavolt ampere, 1200 kilovolt, transformers become too large to enable transport. After this brief look at the history of transformers, we will now delve more closely into the energy transmission chain and the role of transformers.